So welcome back everyone. Good evening. Welcome back to the NPTEL online course on water and wastewater treatment for problem solving and doubt clarification. Now we are in week 8, and as you all know, the course instructor for this course is Dr. Bhanu Prakash from IIT Roorkee, and I am one of the teaching assistant. My name is Akash Saha, and I am a PMRF scholar at the Department of Civil Engineering at IIT Madras, where I am pursuing my PhD in environmental engineering. Okay, so let us quickly go through the contents of week 8. So in week 8, we have learned about coagulation, what is the alkalinity requirement of various alum salts, okay, and what is the operating regions of ferric salts, their solubility, and all these things, different kinds of coagulants we have seen. And then we learned about rapid mixing, what are organic coagulants, about jar test, okay, what are the different conditions and what do we get from a jar test. And then what are the types of rapid mixing design, what do you mean by mean velocity gradient. And then we learned about flocculation, what is the goal and mechanism of it, what are the different types of flocculation basins, what is the design of a basin and the paddle flocculator, and then types of settling where Stokes law is dependent. And then after discrete settling, we also have seen about the flocculant settling or the type 2 settling. Okay, so what is the critical design parameters and what are the primary design variables for this. So all these things were the contents of week 8. Okay, majorly coagulation and flocculation in detail. So I have some questions, and mainly today we will be solving numericals because there are many numericals related to coagulation and flocculation. So mostly we will be dealing with numericals, okay, and numerical answer type questions, and in between I have some MCQs also. So let's see. So the first question, it says that a lake water contains, okay, carbonate and bicarbonate ions at 4 into 10 to the power minus 3 and 5.6 into 10 to the power minus 3 equivalents per liter. Okay, so the concentration is given in equivalents per liter. If pH of lake water is 9, then find out the alkalinity in terms of milligram per liter, okay, as CaCO3. So as you all know, alkalinity is basically expressed in terms of carbonates, bicarbonates, hydroxide, and also the acidity that so not acidity, the H plus ions that is also removed from it. Okay, so this is nothing but the acid neutralizing capacity, alkalinity. So we have to find the alkalinity of this lake water where all the concentrations are given in equivalents per liter, and the pH of the water is also given. And here there are no, yeah. So these are all the information that is being given. So now you have to calculate the alkalinity. So if you want to try, you can please go ahead because it's a numerical type of question. We don't have any uh, multiple choices for this. So, or else you can just let me know like how will you proceed? How will you proceed if this kind of question comes? What formula you will use? Any idea? So we have to calculate the alkalinity in terms of milligram per liter as CaCO3. Okay, everything is given in terms of equivalence per liter. So we have to majorly do here unit conversion. So that is the main criteria. Okay, I think it's better if I start solving it, then you will get some idea. Maybe in the later problems you can solve and tell me the answer. So I hope you have noted down the problem. So just a minute. So week 8, right? So this is question number 1. So when we say total alkalinity in equivalence per liter, it is nothing but the concentration of the bicarbonate plus 2. This 2 is coming due to the charge. So carbonate ions, 2 into carbonate ions plus the hydroxide, okay, minus the H plus. So this is how we define alkalinity. all these concentrations added minus the hydrogen ion concentration. And then if we convert this total alkalinity in milligram per liter as CaCO3, what would happen? So simply we have to take, suppose carbonate ion concentration is there in milligram per liter. Okay, you have to change in terms of as CaCO3. So we will multiply it with equivalent weight of CaCO3. So everything is terms of CaCO3 divided by equivalent weight of carbonate ion. Okay, so this is the first one. Then plus again in milligram per liter into equivalent weight of CaCO3 divided by equivalent weight of HCO3 minus. Then plus again OH minus in milligram per liter into equivalent weight of CaCO3 divided by equivalent weight of OH minus. And at last minus H plus in milligram per liter into equivalent weight of calcium carbonate into equivalent weight of H plus. Okay, so everywhere whenever anything, so this is the overall formula for finding out alkalinity. So anything, suppose anything X is there in milligram per liter, so it will be nothing but X in equivalence per liter into its equivalent weight of X into 1000. So that is how we do. So anything, if you want to find in milligram per liter, we have to just multiply the equivalent per liter into equivalent weight of X into 1000. Now we know that pH is given as 9. So if pH is 9, what will be my POH? What will be the POH? Any idea?
5.
Yeah, 5. It will be 5 because pH plus POH we consider for any aqueous uh, solution as 14. So POH will be 5. So if pH is 9, my H plus ion concentration will be 10 to the power minus 9 moles per liter. Okay. And if it is given in moles per liter, so I will convert. So I can write 10 to the power 9 moles per liter, or into 1000 into equivalent weight 1. So it will be 10 to the power minus 6 milligram per liter. Okay. So I am just converting into milligram per liter. Or I can also write it as 10 to the power 9 equivalents per liter. Okay. Then OH minus, same 10 to the power minus 5 moles per liter. Or I can write 10 to the power minus 5 equivalents per liter. Both are same because the equivalent weight is 1. For CO3 2 minus, the equivalence that is given in the question is 10 to the power minus 4 into 10 to the power minus 3 equivalents per liter. So you have to just, so for converting into milligram per liter, it will be 4 into 10 to the power 3 equivalents per liter into what I told, equivalent weight of X. What is the equivalent weight of carbonate? Any idea? What is the equivalent weight of carbonate?
Sir, 30.
30. Yes, because the total weight is 60. So 60 by 2, it is 30. So
Yes, sir.
60
Yes, sir. Correct.
into so into 1000, right? So this is the formula. So in milligram per liter, I will get 120 milligram per liter. Then HCO3 minus again 5.6 into 10 to the power 3 equivalents per liter, or 5.6 into 10 to the power 3 into equivalence equivalent weight of bicarbonate 61, okay, into 1000. So it will be 341.6 milligram per liter. Okay, so everything I have calculated in terms of milligram per liter, right? And yeah, one more thing, this OH also we have to find in milligram per liter. So it will be 10 to the power minus 5 into 1000 into 17. Okay, so it will be 0.17 milligram per liter. So we got everything in milligram per liter now. So we will now put it in the formula, that actual formula which I wrote, that big formula. So total alkalinity, okay, in terms of milligram per liter as CaCO3. So that would be, so first carbonate, it's 120 into equivalent weight of calcium carbonate divided by equivalent weight of carbonate, plus what is my HCO3 minus into equivalent weight of calcium carbonate by equivalent weight of bicarbonate, plus OH minus 0.17 into 50 by 17 minus 10 to the power minus 6 the hydrogen ion concentration into 50 by equivalent weight of 1. So if we solve all of this, we will get something around 200 plus 280 plus 0.5 minus 0.0005. So the answer would be 480.49 milligram per liter as CaCO3. Is it okay? Okay, now can someone tell me, we here we got everything in terms of milligram per liter, right? So why can't we just add it up and say this is the total alkalinity? Why we are converting all those things we are doing? Why can't we just simply add it and tell the alkalinity? Is it possible?
Sir, actually, milligrams per liter, na, it means parts per million value, ना.
Okay.
इसके
So
लिए
now why we are converting everything?
not understanding question clearly.
No, so the reason of all this conversion is because we are converting everything in terms of Ca calcium carbonate. Okay, these milligram per liter, whatever is we have found out, this is the concentration of that particular ion, of that particular molecule, like OH minus or CO3 minus. We cannot simply add and tell. So we are converting everything in terms of this CaCO3 and then reporting the value. Okay, so strength in terms of CaCO3 we are telling. Suppose you might have heard about this greenhouse gases. Okay, we report greenhouse gases in terms of, yeah, that is basic in nature. That I'm just saying in terms of reporting. Whenever we want to report something, we bring it in terms of a singular unit so that we can use it everywhere. So suppose greenhouse gases are there. We are reporting in terms of kg CO2. 1 minute. Yeah, kg CO2. Why we are doing that? There are so many greenhouse gases, right? There can be nitrous oxide, there can be methane, there can be so many types of greenhouse gases. But what we do, we convert everything in terms of the strength of CO2 and then report it as total kg CO2 of greenhouse gases. So like that only, if we have the alkalinity in milligram per liter in the form of each ion, but to uniformly understand it, we are converting everything in terms of CaCO3 and then reporting. So it's just a way of representation. Okay, so that for universally we can understand it properly, right? Because Suppose, so example, the impact of nitrous oxide is much more than methane, the harm. Okay, so how will you like compare the emissions from these two gases? Okay, there is no comparison. Both have different impacts. So that's why we convert everything in terms of CO2 and then report it. Just I'm giving you some uh, like background of why we have to convert it. Okay. Okay, that is not majorly concerned for our problem. For our problem, we have to just take care about this formula. Okay, so whatever values are given in milligram per liter, we have to change into, we have to multiply that into the equivalent weight of calcium uh, carbonate divided by the equivalent weight of that particular thing.
सर आई हैव अ डाउट
Yeah,
सर एक्चुअली अपना प्लांट में हम लोग टोटल अल्कनिटी चेक करते हैं
हाँ
वाटर सैंपल का बाय टाइट्रेशन मेथड
हाँ
H2SO4 0.02 नाइट्रोमिलिटी के साथ
हाँ,
वहाँ
yes.
पे हम लोग सपोज कोई वाटर सैंपल लिया तो उसमें अगर हमको इंडिविजुअल बाइकार्बोनेट्स कार्बोनेट्स हाइड्रोक्साइड आयंस अगर हमको पता करना हो तो कैसे पता करेंगे हम
हाँ
लोग टोटल अल्कनिटी एज ए कैल्शियम कार्बोनेट कैलकुलेट करते हैं ना सर
हाँ, yes. So
तो
see
अगर हमारे
this
पास यस
hydroxide, bicarbonate, there are various endpoints. Like first you have to titrate with phenolphthalein, then you have to titrate with methyl orange.
यस
Okay,
यस
so
फिर
step
आप
by
से करें तो हमको फिर अपनी अल्कनिटी मालूम हो जाएगा
हाँ
तो एक्चुअली क्या है कि सर अगर हमारा कार्बोनेट अगर सपोज वाटर में कार्बोनेट प्रेजेंट है तो उसका सर पीएच वैल्यू कितना होना चाहिए कहाँ तक हो सकता है उसका पीएच वैल्यू
carbonate means I think 4 to 5.
ओके अगर बाइकार्बोनेट है तो थोड़ा सा ज्यादा होगा ना
Yes,
पीएच
yes,
अगर हाइड्रोक्साइड आयन है तो पीएच हमारा ग्रेटर देन 10 हो जाएगा
yes,
ऑलमोस्ट
yes, yes,
करेक्ट ना बट
yes, yes.
सपोज हमारा कोई वाटर सोल्यूशन लिया सपोज हमने कूलिंग टावर वाटर का सैंपल लिया उसका पीएच हमारा एवरेज में 8 है फिर भी
Yes.
उसमें टोटल अल्कनिटी हमारा ज्यादा आता है
Okay.
ऑलमोस्ट 130 140 आता है उसमें हमको अगर कार्बोनेट्स बाई कार्बोनेट्स पता करना हो उसमें तो हाइड्रोक्साइड आयंस तो नील होगा सर ऑब्वियसली
नहीं वो आपको you have to measure and check, right? Phenolphthalein indicator से then methyl orange indicator, then we have to subtract it and then find out
वही
step
उसका
by step.
पीएच हमारा कूलिंग टावर का पीएच हमारा 8.3 से बिलो है फिर भी उसका पी अल्कनिटी लीन आता है मतलब नील आता है नहीं आता है जीरो शो
Okay.
करता है बट उसमें
Okay.
टोटल अल्कनिटी हमारा सर ज्यादा आता है 130 तक आता है
Okay. Then there is no hydroxide. फिर उसमें we have to find out in terms of bicarbonate and carbonate.
यस यस उसको इंडिविजुअली अगर हमको पता करना हो कि उसमें बाइकार्बोनेट कितना आयंस है और बाइकार्बोनेट और कार्बोनेट कितना कितना अलग अलग है उसको कोई मेथड है कैसे चेक करेंगे
Okay. I'm not I'm not able to recollect now. I will get back to it. Okay.
ओके सर
Okay.
थैंक यू
Hmm. Okay. So I hope this question is clear to all of you. So the same thing is being reported here. Okay, so total alkalinity in terms of equivalents per liter, then milligram per liter as calcium carbonate. So for that, we have to do all these conversions. Now, next question. So it says that a 15 milligram per liter alum dose is applied to coagulation tank having a capacity of 15,000 meter cube per day. Then calculate the alkalinity consumed in kg per day. Okay, so you know the discharge and also the alum dose. So you have to find out because of this alum how much alkalinity will be consumed per day. So that is the question. And the formula is also given. So any idea how to proceed with this? The formula is right there. So the alkalinity consumed will be proportional to what? Any idea? The alkalinity consumed will be proportional to what? Alkalinity is nothing but the acid neutralizing capacity, right? So how much moles of alkalinity will be consumed? What do you think?
Sir, I think it's based on pH, water pH.
That is based on the H plus ions. So okay,
Yes, it's H plus
that
ions.
many moles alkalinity will be consumed. Okay, so
Yes.
here 6 is. So simply what we have to do, that formula, what is the formula given? So yeah, the formula given is Al2SO4 thrice dot 14H2O gives 2AlOH
Main node clean
plus 6H plus 3SO4 2 minus plus 8H2O. So this is for the number of moles of H plus that is being liberated. Okay. So based on that we can calculate. So we have 15 milligram per liter of alum, right? And 1 mole of alum. Okay. What is the weight of alum? So if you find out the molecular weight of this, it will be 594. So it is 594 gram of alum, right? Into we have 6 mole of H plus per mole of alum. So 1 mole of alum will give 6 mole of H plus, and this and per and everything we want to convert in terms of uh, CaCO3, right? So it is 50 gram of CaCO3 per equivalence of alkalinity, or per mole of H plus, you can say. So per equivalent weight of alkalinity or H plus. So 50 grams of calcium carbonate equivalence will be produced. So if you multiply all of this, you will get 7.57 milligram per liter as CaCO3. Okay, and simply if you just multiply it with the discharge, milligram per liter into the discharge, you will get 113.55 kg per day of alkalinity consumed. So concentration into discharge, if we do, we can get the amount of alkalinity that is being consumed per day. Okay, so based on your number of moles of your acid being released or H plus being released, we have to find out the alkalinity. Okay, so no need to like be aware of all these units. Is just to make your understanding. It's simply 15 into 1 by 9 594 into 6 into 50. That's all. So whatever. Now suppose you want to know how much of sludge will be produced or how much of precipitate will be formed. So that will be based on the molarity of ALOH thrice. Okay, so based on these many moles, so per mole of alum, 2 moles of ALOH thrice will be produced. So always this formula will be important to find out the concentration or the amount or the mass of any chemical in the system. If you know the formula, you can solve it in any way. Okay. I hope it is clear. We'll move forward. So same thing is given. Yes,
Sir, what is the difference in between basicity and alkalinity?
base basic we say basic nature whenever the pH is more than like uh, the 7. Okay, so in pH scale whenever it is more than 7, it imparts it is called as basic, whereas alkalinity is anything that can consume your acidity or acidic nature.
Then,
Okay,
sir,
so
how you can decide,
no,
sir?
like I am saying that like this carbonate, bicarbonate, okay, these can be a part of your acidity also and alkalinity also, because some part will consume your uh, basic nature property and some part can consume acidic nature property based on their like constituents. How to explain this? Just let me go back to the previous problem. Yeah, see. So when we say alkalinity, alkalinity is defined by the amount of bicarbonate, carbonate, hydroxide minus the acidic behavior. That is the H plus ions. And when we define acidity, so what are the constituents of acidity? Again,
H positive
we
ions.
have bicarbonate, we have carbonate, and we also have this carbonic acid minus the OH minus. So you see, these two things are can add act as an acid. It can accept an electron also, a proton also, and it can give out a proton also. If this HCO3 minus, if it accepts a acid, okay, it will give H2CO3, right? So it can accept a proton, and same from this, if a H plus is getting removed, it will become bicarbonate also. So these has dual nature. Okay, so we cannot say alkalinity will be same as basicity. Basicity is anything which is more than pH scale of 7, we call it as basic nature. But alkalinity we define as whatever ions or whatever molecules are able to take the protons will be, or neutralize the acid, we will call it as alkalinity. Are you able to understand? Is it clear?
Yes, sir, yes. NaOH and KOH is the base.
Yeah, yeah. So
And
whatever, so
they do
those,
not contain the OH negative, sorry, having not capacity of donating and accepting the proton.
no, I am saying that OH minus can also take a proton, right? They can also combine with H plus and form water. Okay, so whatever is there, so OH is both basic and it also contributes to alkalinity. Okay, but CO3 2 minus doesn't always mean that it can only act as a basic. It can also act as a alkalinity also and
Acid.
acidity also.
Okay, okay. Okay, sir. Thank you.
Okay. So all these terms will like they are very similar when we say in our norm like usual language, but just see what are the basic constituents of it and then try to understand. Okay. Okay, the next problem. It's a MCQ type. So it says that select the correct answer regarding mean velocity gradient G and the retention time T in a flocculation tank. Okay. So it says that higher G and smaller T leads to smaller and denser flocks. Higher G and higher T leads to breaking of flocks. Lower G and higher T leads to larger and lighter flocks, or all of the above. Okay. So what is G? Like what does G indicates? What do you mean by it? It is called as mean velocity gradient, but what do we mean by it? Any idea? Yeah, that's what we
Yes.
say. But what does it represent? What do you mean by if I am saying high
Addition
G,
of all the velocities.
addition of all the velocity? No, this is
You
velocity
have to
gradient.
calculate the mean of
No, it is
that
not a
velocity.
mean of all the velocities. Okay.
Hmm.
It won't make any proper sense here. So it is the mean of velocity gradient. Yes, that is correct, Amit. So excessive shear, it says that what is the measure of the intensity of mixing. Okay, what is how much shear stress it is being providing. If high G means high shear stress, means the intensity of mixing is higher, whereas a low G means the mixing intensity is lower, and so the shear stress will be lower. So that's what it indicates. And retention time is nothing but the time you are giving to form the flocks. So now try to understand. So if I give more time, suppose let's see the first part. It says that higher G value, that means mixing intensity is very high, but time is small. So what will happen to the flocks? Will it be smaller and denser? Just think about it. And then in the next one, we are giving again high intensity, but time is also very high. So will it break my flock? So like that you have to analyze. And then tell me which one will be the correct answer.
B, sir.
Okay. Any other answer? A and C. Okay. So someone is telling B, someone is telling A and C. So that means all are correct. Is it? Anyone thinks that all of them are correct?
Yes, sir. Yes. Because in the C option there is lighter flux.
Yeah. Okay. So just try to go one by one in all of this. So first one is saying higher G. So intensity is very fast. Okay. So when intensity is very fast, the particles will become very close to each other. It will form, and you are giving small time. Okay, small time. So the flock size will be very small, and since the particle will be coming very closer to each other, it will form a denser flock. So it is true. So when high G and low T, it will form small and denser flocks. Now we are giving high G, so flocks are being formed because particles are coming near to each other, but the time is very high. So when the time is very high, so that means like it is more exposed to the shear stress for a longer period of time. So ultimately, the stabilization will not happen and it will start breaking. Okay, so more and more shear stress you are giving for more amount of time. So the formation of the flocks will not happen and it will break. Now lower G, the intensity is lower. So particles will come closer but not form a dense flock. Okay, it will slowly attach with each other, and time period is also high, very high. So it will so slowly attach to each other, and it will form a larger and a lighter flock. It will not be very dense. It will not come very near to each other. Okay, so I hope you are able to understand all these three phenomena. So when it, so so based on the G value and T value, we can govern the size and the type of flock, whether it will be small or large, or whether it will be dense or light. Is it okay? Fine. Now next one. Uh, Flocculator is having a flow rate of 35,000 meter cube per day and a detention time of 20 minutes. Calculate the power required in kilowatts for the paddle to achieve mean velocity gradient of 22 per second. The water is having a dynamic viscosity of 1.04 into 10 to the power minus 3 Pascal second at 20 degrees Celsius. So you have to find out the power for the paddle. There is a direct formula through which you can find out. So what is the formula? Anyone knows? G equal to square of P upon V by mu. That is true. Yeah, square root, yeah. Not square, square root. That is true. So if you want to try, Please try and let me know the answer. I will wait for a minute. Just tell me the final value in kilowatts. Okay. So answer we need in is in kilowatts, not in watts. So for that formula, the formula is G is equal to under root power by V mu. Okay. So G is known, power we have to find out, V is not known and mu is known. So we have to first calculate the V. So we can easily calculate the HRT is given. Okay. So we know theta is equal to V by Q. So from here theta we know it is as 20 divided by V into V divided by Q. Q is 35,000. Okay, so we will get V as 486.1 meter cube. Right? Now we will just put it in the value. So G is 22 equal to root over P. V is 486.1 into the mu. Okay. So if you solve this, you will get P something around 244.68. Okay, or you can say 244.7 watts or 0.244 kilowatts. So answer will be 0.244 kilowatts. Right? I hope this is clear to all of you. There is nothing much, just direct application of the formula. Right? Next problem. 3 circular sedimentation tanks shown below have the same dimensions. Here Vs, V0, Ts and Dt are settling velocity, surface overflow rate, settling time and detention time respectively. Okay, so we all are familiar with these notations. So choose the correct option about 100% removal efficiency for particles having Vs greater than or equal to V0. Okay, so it is saying that 100% efficiency will happen if the settling velocity is greater than the overflow rate. Okay, so in tank 1, Vs is greater than V0. In tank 2, Vs equal to V0. And in tank 3, the settling time is less than the detention time. So what do you think? Which tanks will have 100% removal? Okay, what about B? So you just read it properly. It is given that choose the correct options about 100% removal efficiency for particles having Vs greater than or equal to V0. So equal to is also a part of it. So if it is equal to V0 also, then also 100% settling will happen. Okay. So now tell me what are the correct answer. Option B. Okay. What about the third tank?
Sir, all of them?
Yes, ideally all of them will have. So why do you think the third tank will also have a settling 100% efficiency?
Because of more detention times.
Yeah, so that means, see, the particle settling time, suppose the particle settles in 1 minute, but you are giving time for 2 minutes. Okay, so that means what? All the particles will get settled because settling time is only 1 minute. You are giving more than that. Okay, detention time means the time for which the water will be there inside the tank. So definitely all the particles will get settled. So in each of these tanks, there will be 100% settling efficiency. Okay. So the correct answer is D, all the three tanks. So first two, definitely it is given in the question itself. So if Vs is greater than or equal to V naught, we will get 100% settling efficiency given in the question. But also if the settling time is lesser than the detection time, all the particles will. Uh, no, like what do you mean by real condition? See, in real condition, first of all, there will be flocculent type of settling mostly. Discrete type of settling will not happen. Okay. But if you see any grid chambers and all, where only you want the sand or grit particles to settle down, so there you can have all this. So there you will get in real terms also 100% settling. Okay, but usually in sedimentation tanks, there may be flocculent type of settling. So there you cannot like judge based on this. Next
Excuse
question.
me, sir.
Yes,
Please explain the third tank, sir.
third tank.
How it?
Okay,
Yes, sir.
yeah. Like suppose in this tank, the water is moving like this, right? Okay, and particles is settling like this. It will try to settle. Now to cover this much distance for a particle, the detention time that the particle will stay inside the liquid or the tank is, suppose I am saying, giving 2 hours. Okay, and the settling time of, now the condition was Ts is less than dt. And suppose the settling time of any particle, the time for settling is less than 2 hours, suppose 1.5 hours. Ts is 1.5 hours. So what will happen? So before the particles comes out of the system, it will definitely settle down because it is less than the detention time. So what does that mean? It means that all my particles will settle down. So if all my particles is settling down, that means 100% settling is achieved. So my efficiency will be 100%. Is it clear?
Yes, sir.
Okay. Next, select the correct options about coagulation using alum. Okay, so alum coagulation statements are given. Alum forms the precipitate AlOH thrice at high pH. Alum imparts red color in water. At high pH, most of the aluminium in water stays as free metal Al3 plus ions. Adsorption and charge neutralization will not take place during coagulation. So what do you think? Which of the statements are correct?
Sir, A and C.
A and C. Okay, so it is saying that A and C, to be honest, are both contradictory points. Okay, If A happens, then C cannot happen. If C happens, then A cannot happen. Do you know why? So both are saying that in high pH. So statement A is saying at a high pH, precipitate will form, and statement C is saying at high pH, the metal will be in free form, Al3 plus. Okay, so just go through the statements once again. So both are contradictory, because if aluminium is getting precipitated, it cannot be in free form, right? And if it is in free form, like in Al3 plus form, then how it is forming the precipitate? So any one of them can be true. Now tell me. So the correct answer is only A, because at high pH only this alum will form a precipitate of AlOH thrice. Okay, and alum will not impart any color. Then alum will not stay as free metal ion at high pH, and definitely during coagulation the absorption and charge neutralization can happen. Okay, so B, C, D are incorrect. So the correct option is only A, that alum will form precipitate at high pH. That we all know, that is a well-known fact. At a certain pH only it will form the precipitate. That is true for most of the coagulants. It will work only at a particular pH range. Beyond that, be uh, it will be available as a free metal ion, like ferric chloride or alum, whatever. Again, a small numerical. Yeah, so whenever alum is being used, as you have seen in earlier one of the equations, it will give out H plus ions, right? It will give out H plus, so pH will decrease.
यस सर, इसीलिए बाइकार्बोनेट से ऐड किया जाता है ना।
Yes, yes, to neutralize it. That's why we in last class we did one question also, that how much alkalinity will be required if we are using alum. Okay, so that problem also we have solved last class. Okay, now next problem. It says that a chemical supplier reports the concentration of stock alum chemical as 9.58 percentage as Al2O3 with a specific gravity of 1.23. So calculate the molarity of Al3 plus. So these questions are not related to any coagulation, flocculation, anything. These are simple chemistry. Okay. So there are different ways in which we can represent any chemical or any compound. Sometimes we will represent in terms of ions like Al3 plus. Sometimes we will represent in terms of compound, okay, as Al2O3 or alum or some hydrated compounds. So in any form, we should be able to calculate the molarity or the concentration of that particular species. Okay. So here also they have given that alum is being reported as 9.58% as Al2O3. So now you have to tell me what is the molarity of Al3 plus. So think about it, how we will solve this problem. Any idea? Any idea? Okay, let me solve it. I hope you have noted down the problem. Okay. So what was the density given? So density of the stock solution was 1.32 kg per liter. So per liter, the mass is kg at 1.32 kg. Now suppose I want to know the concentration of the Al2O3. Okay. The stock chemical is given as Al2O3. So my concentration of alum in stock chemical as milligram per liter of Al2O3, because we know only for Al2O3, right? So for Al2O3, so my C concentration of my stock will be, it is given 9.58%. So 9.58%, okay, into what? Into the density. So density is 1.32. So that is in kg per liter. Okay. So I will just change the kg to gram. So it will be 1000 gram per kg. Okay, so if we calculate it, so it will be 126.456 gram per liter of Al2O3. So per liter, 126.456 gram of Al2O3 is present. Okay, because whenever we are calculating the molarity, we should know what is the weight or what is the moles present of my compound. What is the moles present, right? Now, what is Al2O3? Al2O3 is nothing but 2 into 27 for aluminium plus 3 into 16. This is the molecular weight of Al2O3. So 102 gram per mole. This is my. So now we have to find out the molar concentration of Al3 plus. So now instead of Al2O3, we are going to find out the concentration of Al3 plus. So what it would be? It would be 126.456 gram per liter of Al2O3. Okay. And if I want to know the number of moles, so 1 mole of Al2O3 will be having 102 grams of Al2O3. Right? I am converting the grams to moles because for molarity I want to know the moles. So that's why I changed. Now in each Al2O3, how many Al3 plus ions are there? 2 Al3 plus ions are there and 3 O are there. Okay, so I will just multiply it with 2 mole of Al3 plus per mole of Al2O3. Okay, because we are calculating the molar concentration of Al3 plus. That's why I multiplied with 2. If we are finding the molar concentration of Al2O3, this part won't come. The last part into 2 won't come. Because per mole of alum, we have 1 mole of Al2O3 only. So we have to see what species we are, for what species we are finding out the molar, like molarity. So into that many times we have to do it, multiply it. So this will come out as 2.479. So gram will cancel, mole will cancel. Okay. So this much moles of Al3 plus per liter. Right? Liter will be still there. So per liter. So moles per liter is nothing but molarity. So 2.479 molar Al3 plus. Is it clear to all of you? Just look into the problem once again and try to understand. So whenever you are asked for a particular species like Al3 plus or Fe3 plus, you have to multiply with the number of that particular species present in the molecule or number of moles of that particular species in the molecule. Okay, very simple. Okay, now this problem you have seen. Now next problem is based on this, the previous problem only. It is said that calculate the concentration of alum from the data given below. So we have to express now the concentration in terms of alum. So now tell me what, and the alum formula is also given. So we have found out the concentration in terms of Al2O3, right? That's so much gram per liter of Al2O3 we got in the previous. Now we have to convert in terms of alum. How will you do? Tell me. This is a very direct and simple question. It's just unitary method. So suppose we got X gram per liter of Al2O3. So if you want to convert into some particular grams of alum, so how will you change it? Please calculate and tell me the answer. I'll wait for some time. No idea? Anyone? So here we got, right, 126.456 gram per liter of Al2O3. So the same thing. So concentration in terms of alum, if I want to do, it will be 126.456 gram per liter of Al2O3 into the weight of alum. So what is the weight of alum? So if you solve that for whatever formula was given, so it will be 594 gram per mole of alum per 102 gram per mole of Al2O3. Simple, like we how we used to change in equivalent weight, the same thing. So it will be 736.42 gram per liter of alum. So in terms of alum, this is 736.42 gram per liter as alum. One step answer. So this is the weight of that, whatever was the question. Yeah, Al2SO4 thrice dot 14H2, and 102 was the weight for Al2O3. And also you be careful, because in many places alum concentration is given as Al2SO4 thrice dot 18H2O. In some places it is given as 14H2O. So just see in the question and solve accordingly. Okay. Next problem. What happens when alum is mixed in water as a coagulant? We just now discussed. What happens when alum is mixed in a water as coagulant? A. Definitely the pH will be decreased. So obviously A. In water treatment, a jar test is performed. So what are the reasons? To find the chlorine content of water, to obtain optimal dose of content coagulant, to find out the optimal time required for flocculation, to find out optimum pH at which coagulation needs to be done.
B, sir.
Only B. Any other answer? So B is definitely the answer, one of the answer, because jar test is being performed to find out the optimal dose of coagulant. But apart from that, it is also used to find out the
B and C,
optimum
sir. Sorry,
pH.
A and B, sir.
No, pH. So also the pH, the optimum pH at which the coagulation will happen is also being assessed with the help of the jar test. Okay. So that is also very important, that at what particular pH the like the effective coagulation is being performed. So that is also very important, which we calculate from the jar test. Okay, next problem. What are the concentration of iron and chloride in 3 molar FeCl3 solution? Okay, so we have 3 molar FeCl3. Just now we have solved a similar problem. So now you have to tell me what is the molarity of iron and chloride in FeCl3 solution. There is no need to calculate anything, just by seeing you can tell me.
B.
B. Any other answer? Anyone else? Or you think B is the correct answer? It can be C. How it can be C? Any particular reason? So here the concentration is given. It's a 3 molar FeCl3. Okay. So what will be the molarity of the ions, individual ions?
Sir, C, sir.
Why C?
It's ratio, sir. 1:3.
See, yeah, ratio is 1:3, but so by ratio we mean to say that per mole of FeCl3, okay, per mole or per molar FeCl3, we will have 1 mole of Fe3 plus and 3 moles of Cl minus, right? This is clear to all of you. Per mole of FeCl3, we will have 1 mole of Fe3 plus and 3 moles of Cl minus. Now here the number of moles is itself is 3, because it's a 3 molar solution. So Fe will become 1 into 3, 3, and Cl minus will become 3 into
3
3,
3.
9, right? So it will become, so the correct answer is 3 molar FeCl3 and 9 molar Cl minus. Is it clear to all of you?
Yes.
Yes,
Okay.
sir.
So always see what is the final molarity given. Whatever you analyze, the ratio is fine, 1:3, but the molarity we have to multiply with the times of number of moles that is present. Okay, actual number of moles. So 3 and 9. Okay. Tapered flocculation is more efficient when compared to conventional process of flocculation, as it improves aggregation of smaller particles into larger aggregates to enhance their removal by gravity. So is it true or false?
True.
It is definitely true because we have seen in the first problem itself like how G and T like helps in governing the size. So tapered means slowly, like from increasing to decreasing it will happen. Okay, so that's what we mean by taper. So from smaller particles slowly we will move into larger particles, larger size particles, okay, to enhance the removal by gravity. So that is true, and the reactor size doesn't matter. Okay, in any size we can do it. Next question. Match the following flocculation mechanisms with their characteristics. So we have a perikinetic or a orthokinetic mechanism or a differential settling. So what are their particular characteristics? So just match and tell me. So perikinetic is micro scale, orthokinetic is macro scale, and differential settling is like what is the let
A1, sir. A.
sorry A.
A.
So how you are saying it as A?
Perikinetic cause when microparticle differential settling velocity is true. And third one, differential setting caused by relative motions of fluid.
No, just think over it. I don't think it's the correct answer. So just think about micro scale. So micro scale means at what level you will control the motion.
Sir,
Brown's
D, sir.
motion.
Brownian motion, right?
Yes,
Sir,
Brown
D,
motion.
sir.
Yes,
So perikinetic will be for Brownian
Brown
motion.
motions. Yes, yes, yes.
Orthokinetic will be for
For first one,
relative
differentials.
motion of fluid. Relative
Yes, yes.
motion at a macro scale. You are not
Uh,
going into a micro scale, you are going into macro scale. And
macro. Yes.
differential settling means differential settling velocity directly. It's there in the name itself. Okay, so the correct answer will be D. So differential settling means caused by particles having differential settling velocities. Perikinetic means the mechanism that is governed by the Brownian motion. We are going into the micro scale. And for macro scale, it is just relative motion of fluid. Okay, so these are just different mechanisms. Just don't worry about it much. Okay, you don't have to know in detail. Just to give you some context. Okay, next another problem. So today there are more problems actually. Consider a coagulation treatment plant where the flow is this much, alum dosing is also given, the influent and the effluent suspended solids concentration is given, the alum stoichiometry is also given. We have to find out the total dry solids that is produced per day. So if you remember in one of the previous problems I was discussing, like to find out the sludge quantity, we have to see how much AlOH thrice is being produced. So based on that ratio only, we have to solve this problem. Just go to the problem again and then we will solve it. Or just take a screenshot of it. Okay, so this stoichiometric equation is very important. Many a times it is given, but many a times it is not given in the question. So try to remember this. Okay, so because every time based on this stoichiometric equation only, we will solve the problem. Right? So question number 14. So we have the flow as 0.15 meter cube per second, or we can say 12960 meter cube per day. Okay. Now 1 mole of alum is giving 2 moles of, because we are finding out the sludge, so 2 moles of AlOH thrice. Okay, you have seen the equation, right? So I will write it out down again. So Al2SO4 thrice dot 14H2O will give 2 AlOH thrice plus 6H plus 3SO4 2 minus plus 8H2O. So for alkalinity we have to see this, for sludge we have to see this. So what is the weight of alum? alum is 594, Al2OH is 78. Okay, these are the weight. So what does it mean? It means that for 594 grams of alum, we will get 2 into 78 grams of AlOH thrice. Okay, this is the sludge. So for 1 gram of alum, we will get 2 into 78 by 594. Now alum dose is given as 22 milligram per liter alum is being dosed. So for that it will be 22 into 2 into 78 divided by 594. So we'll get it as 5.786 milligram per liter of solid sludge. So this much of sludge is being formed from the alum. This is from the alum. Okay, but in the question some influent and effluent suspended solids are also there. Okay, so that will also form some sludge. So what is my solid removed? Suspended solids removed. So influent concentration was around 30, effluent was 15. So 30 minus 15, 15 milligram per liter. So this much of SS is also being removed. Okay, so my total dry sludge that is being removed. Okay, dry sludge solids removed, it will be 5.786 plus 15. So it will be 20.786 milligram per liter. So what will be my weight? So total dry sludge solids removed per day. So per day it will be 20.786 milligram per liter into the discharge. Your discharge is 12960 meter cube per day, and to change to kg to gram, 1000 gram. So you'll get 269.387 kg per day. Is it clear to all of you? So very simple. Based on the formula, first find out for the sludge and then calculate how much solids are being removed, add it, then find out the solids removed per day by multiplying it with the discharge. Very simple. So this is the discharge. So 0.15 meter cube per second, I just converted into meter cube per day. So that is 12960. Right, so this is the answer. Next problem. A flocculation chamber has 12 meter long, 0.25 meter wide paddles. Both paddles are supported parallel to the horizontal shaft. Okay, so two paddles are there. The shaft rotation speed is 6 rotations per RPM. Center line of the paddle from the shaft is 1.8 meters. Coefficient of drag is 1.8. Ratio of the velocity of the paddle with respect to water to velocity of paddle from the fixed coordinate is 0.75. Power consumption of the shaft we have to find out. So again, it's a direct formula. All the parameters are given. You just have to apply the correct formula and get the value. So do you know the formula? Anyone who knows the formula? So one power we have seen based on the mean velocity gradient, that is G equal to root over P by V mu. So now it is in terms of the paddle configuration. So what is the formula?
P into area. P is equal to V into area.
V into area, no, that is, yeah. So
Okay.
VP is correct. VP is 2 pi, like K2 pi
Yes,
RN.
yes, yes.
Okay. But
Uh,
for P, with drag force is also there. Okay. Drag force is also there. So the formula is half of CD rho W A into VP cube.
okay.
Okay. So I will just show you the formula. Just wait for a minute. So power when the paddle configuration is being given. So power P is defined as half, okay, CD. CD is the coefficient of drag, then density of water, rho W, then AP, the area of the paddle, into VPQ. Okay, so this VP is nothing but velocity of paddle with respect to water. With respect to water, we have found out because this is moving in water. So this Vp is nothing but equal to K into 2 pi r n. So here K is that coefficient, that 0.75 that is given, into 2 into 22 by 7, into r is the radius is 1.8, into n. N is the number of rotations per minute, so 6 by 60. So it will be 0.8478 meter per second. So once you get the VP, we will just put it back. And AP also we know one area, so that will be length into width. So 12 into 0.25, that is 3 meters square. So my power P will be equal to half. CD is given as 1.8. Density is 1000. Then 2 paddles, so 2 into 3, that is the total area, into Vp cube. So 0.8478 cube. So we'll get the answer as 3290.59 watt or 3.29 kilowatt.
Kilo.
Okay, but the answer, I think it's asked in watts. So yeah, so this is the answer. Okay, this is just, yeah, because we are finding in meter per second, so that's why. It is given as 6 rotations per minute, so we are just converted into seconds. Right, another numerical. So here with velocity gradient they are asking. So similar type of problem, but instead of all the paddle configuration, they are asking the power in terms of the velocity gradient. So all Q, viscosity, everything is needed. So I think there is no point of solving here directly. If you put P is equal to G square mu V, that previous formula, so we will get the answer. Is it correct? Is it fine if I skip this problem or you want me to solve? Okay, I'm just skipping it. Direct. You can uh, like find out the answer and check with the result. 13005 watts. If any one of you wants me to solve it, I will solve it.
No, sir.
Okay. Next problem. Yeah. So it says that a water treatment plant have a flow rate of 504 meter cube per hour. A particle of certain size has settling velocity of 0.14 centimeter per second. Okay. Now the required plan area of type 1 settling tank to remove 90% of particle is. Okay, so flow rate is given, the settling velocity is also given, and you want to remove 90% of particles only. So what will be my plan area? They are asking. Very simple.
A is equal to V upon Q into efficiency.
V upon Q,
Q,
yeah.
Q
Q
upon
upon
means
V.
flow upon settling velocity into efficiency factor.
Yeah, that is true. That is true. So that
Yes.
would be nothing but your discharge Q divided by the settling velocity. Okay, that will give you the area, right? Area is nothing
Yes.
but Q by V. So we'll get the area. So now you only want to remove 90% of that particles. So that area into zero point 0.9 will give you the plan size. Okay. Others, is it fine? I will just quickly show you. So Q is given 504 meter cube per hour. So we will change everything in meter cube per second or meter per second. So it is 0.14 meter cube per second. Vs is known 0.14 centimeter per second. That is 0.0014 meter per second. Now plan area A will be Qy Vs. Okay, so it will be 0.14 by 0.0014. That is nothing but 100 meters square. Okay, now for 90% removal efficiency, it will be 100 into zero point 0.9 area required. Okay, 100 into 9.9, so it will be 90 meters square. So if you are providing 90 meters square, only 90% of the particles will be removed. Okay, next problem. Match the following with the primary design variables. So we have rapid mix design, we have flocculation design, we have type 1 settling design. So what are the primary design variables? You have to tell me. Yeah, tell the answer.
Rapid mixing intensity.
Okay, try the others.
Flocculation design, detention time, and mean velocity gradient.
Is it correct? Anyone else would like to try? So for rapid mixing, both G and T are important. Okay. So always remember for rapid mixing, both G and T are important because that will decide the final type of the size and the like the density of the particle. Okay, so rapid mixing means detention time and mean velocity gradient. For flocculation design, only the mixing intensity is the critical criteria. And for type 1 settling, definitely the settling velocity is important because all this time we are just solving based on the settling velocity. Okay, so always remember that G and T both are required for the rapid mixing for the initial time. Then while flocculation is happening, the mixing intensity is important. Which of the following types of settling phenomenon can be analyzed by sedimentation laws of Newton and Stokes? Very direct, very simple. We have discussed it so many times. What is the answer? So
Discrete.
discrete. So definitely Newton's and Stokes law are only applicable for discrete particle settling. So very simple. Okay, one more problem we'll solve, I think. Yeah. A surface water flow of 15,000 meter cube per day is coagulated by adding 50 milligram per liter of ferrous sulfate. So instead of alum, it is ferrous sulfate and equivalent dose of lime to take care of the alkalinity. So if lime is 87% pure, what is the quantity of lime required? So I have to just calculate the lime quantity. So here, just to simplify your problem, I will just say that 1 mole of ferrous sulfate will react with, or one equivalence of ferrous sulfate will react with one equivalence of lime. Okay, always remember. So with this, you will be able to solve the problem.
56 divided by 278.
56 divided by, no, it's not so direct actually. Okay,
Okay.
because here we have to find out the quantity, okay, in kg per day. So we have to also take the discharge into consideration. I will show you. So I am saying one equivalence will react with one equivalence. So that is always the case. So question number 12. So what is one equivalence of ferrous sulfate? So ferrous sulfate total weight is 287, 278, and combining capacity is 2. So it will be 139 grams. And one equivalence of lime, it is nothing but CaO, 56 by 2. So it will be 28 grams. Now I am saying that one equivalence of ferrous sulfate will react with one equivalence of lime. Or I can say 139 grams of ferrous sulfate will react with 28 grams of lime. Okay, so 50 milligram per liter of ferrous sulfate, what is given in the question, will react with 28 by 139 into 50 milligram per liter of lime. So if you solve it, you will get it as 10.07 milligram per liter of lime. Okay, so we will just multiply it with the discharge. So to get in terms of weight, so 10 is to 10.07 milligram per liter into 15 into 10 to the power 6 liters per day. I am changing milligram to kg, 10 to the power 6. Okay, so we'll get 151.05 kg per day. So this much lime is required, but this lime is 100% pure. Okay, we have not incorporated purity into the picture. So this lime is 100% pure. So we need 151.5 kg per day. So for now 87% pure lime. So for 87% pure lime, it will be 157.05 by 0.87. So it will be 173.62 kg per day. So this much of lime will be required of 87% purity per day, kg per day.
Sir,
Yeah,
just can we solve it in a different way?
yeah, you can solve also in terms like you see that ferrous sulfate, okay, and then we have to form a formula and incorporate how much for each milligram per liter of ferrous sulfate, how much lime is required.
Sir, just I have just one another terms ratio we can take of molar mass of upon molar mass of ferrous sulfate. That is 56 divided by 278.
Okay.
It comes 0.20 something. It
Yeah,
will come.
here actually the combining capacity of ferrous sulfate and lime is
Ah,
2. So that's why your calculation will also hold true for this.
okay.
Okay, but whenever if there are two things where
Ah,
the combining capacities are different, there
ah,
your calculation will not work.
okay. The simple method means mass is equal to concentration into volume.
Yeah.
Then
So
it will something come around
yeah,
500 to 700
whatever
kg
yeah,
per day.
whatever you are saying will be fine if the combining capacity of both the materials are same.
Okay.
Suppose some calcium phosphate is there.
Yeah.
Okay, there
Okay.
the combining capacity is 3.
Ah,
So there if you want to compare with lime, then your calculation won't hold true.
Okay.
Okay.
Okay, sir.
Yeah.
Means I was just multiplying ferrous sulfate dose
Yeah.
into.
I understood what you are doing. Just
Ah,
be aware. But
yeah.
whenever you are doing in terms of equivalence, always your answer will be proper.
Okay,
Okay.
okay.
So
Yes.
never do it in terms of molarity or moles.
Oh,
Okay,
okay.
always do in terms of equivalence, because one equivalent of any substance will only combine with one equivalent of other substance.
Yes. Just randomly I calculated 175 point something it is
Yeah.
coming.
No. But that is not a proper method. So don't follow that. Okay.
Okay, sir.
Right. So that was the question. So yeah, another similar problem I have. Okay, so here also the same stock solution, 8.37 percentage of Al2O3 with specific gravity of 1.32. So same type of problem is there. So you please try to solve it. Okay, and then maybe we can discuss in the next class, or you can send it over to me by mail. So I'm not discussing the similar problem. So that's all for today. Right, we'll meet again next week, 25th March, same Tuesday, 7 to approximately 9 p.m. Okay, and this is my email address, shaha19akash@gmail.com. So if you have any other difficulty also, you can get back to me. Okay, I hope you understood whatever we discussed for today. If you don't have any more things to discuss or to ask, you can leave the session. That's all from my side for today. Anyone who? Okay, thank you so much, Mohan.
Thank you, sir.
Thank you, Stephen.
सर एक क्वेश्चन था असाइनमेंट का, आप कह रहे थे बाद में करवाओगे?
हाँ, yeah, tell me.
क्वेश्चन नंबर 6 रीड करना एक बार.
Question number 6. Can you share the screen? Then I can see the question. Or else let me open it. Yes, what? Which question? Question number?
6 सर.
Okay, sedimentation basin.
Here
Yes. So here you find out the settling velocity of the particle. See,
Okay, sir, I have actually no idea about the formula, or I don't have remember.
no, see, it's already like only one formula is there. Okay, so the same thing we have to apply. So just calculate the settling velocity of the particle from the given information. Everything is given. Density of water, dynamic viscosity, right? All the parameters are given.
I think settling velocity formula is given in previous lecture.
Yeah, yeah. So that formula you can easily take, right? So that settling velocity you compare, and flow rate is
Okay,
also given, and the see flow rate is given, and the basin characteristics are given. Okay, from that you can find out the surface overflow rate, right? Surface overflow rate you can find out, and from the given information you can find the settling velocity also. Now compare the surface overflow rate with the settling velocity and try to solve it, and then see what is the ratio it is coming.
Okay, size of the particle 25. What is it, micrometer or anything else?
Micrometer, that is micrometer, mu m.
Okay.
Okay, so everything is given. Okay, I think there is uh, nothing is missing here. So based on that, you try to solve it. Every data is given.
Okay, let I try to solve, sir.
Okay, you try to solve whatever you solve. You can discuss with me. You can send me over mail. We will check.
Okay, sir. Thank you so much.
Yeah.